All right, so let's get started with this review sheet here. So, given this rational function, 3x over x squared minus 5x minus 14, answer these questions. What's the degree of the numerator? So the degree of the numerator right here, the numerator is 3x. Move my stuff out of the way. All right, so this numerator here is 3x. The degree of that is 1 because it's 3x to the first power, so 1. What's the degree of the denominator? So the degree is the highest power, remember, so I'm going to look here, so the degree is 2. All right, and because of this, this is why our horizontal asymptote is y equals 0. Remember, when the degree on the numerator is smaller than the denominator, then you always get y equals 0 as an asymptote. When they match, like for instance, if we had an equation like, 2x plus 1 over x minus 4, and look at those degrees, they match. So that's when I'm going to take the leading coefficients. So I'm going to take this 2 over the 1 right here, and then the horizontal asymptote would be y equals 2. So that's the other rule. All right, so for that, next question, factor the denominator. So the denominator, that factors into x minus 7 and x plus 2. Negative 7 and positive 2 make the negative 5 in the middle, and then they multiply negative 14. So what are the equations of the vertical asymptotes? So that would be x equals 7 and x equals negative 2. All right, calculate f of 2. So I'm going to plug in 2. 3 times 2, let's see, 2 squared minus 5 times 2 minus 14. So that becomes 6 over 4 minus 10 minus 14. So 6 over negative 20. So that will become negative 3/10. Also, you can do it on Desmos if you like to. All right. So, next question. I've graphed this problem down here. You can see that it's been moved to the right 2 and down 4, and that's what this is asking. So, right 2 and down 4. Right, and from the original parent function. And let's see, what is the domain? So my domain is everything except for this 2 right here, right? Because x can't be 2 because it would make the denominator of the fraction 0. So it's all real numbers where x cannot be 2. Or you could write it like this, negative infinity to 2, parentheses, and then 2 to infinity. And that little U symbol in the middle is a union symbol, and so it just means this section or that section. Right, what's the vertical asymptote? Well, that would be x equals 2. What's the horizontal asymptote? It's this guy right here. That would be y equals negative 4. And remember, the end behavior. The end behavior of a rational function follows the horizontal asymptote. So it follows this guy right here. His graph is coming down to meet negative 4. This one's coming up to meet negative 4. Never touches it. It gets close enough to it that we say the end behavior is negative 4. So the horizontal asymptote and the end behavior on rational functions always match. All right, or unless you have what's called a slant asymptote, but we're not doing that. Let's see, right now it's for 2. So let's see, is this exponential growth or decay? Well, this fraction right here, 3/2, that's bigger than 1. It's 1.5. So this should be exponential growth. Does this function have a horizontal or a vertical asymptote? So remember your basic exponential function. Now don't graph this yet because I'm not doing that. The basic exponential function has an asymptote right here, and then if this was growth, it kind of grows up through there. Okay, so this problem always has a horizontal asymptote, and the equation of the asymptote gets changed if you change the equation. So this thing has been moved down 2, so this line also gets moved down 2. And you see it's been moved down 2, and then the x plus 4 moves it to the left 4. So down 2, left 4. So the graph should be about like this. I mean, it's not going to be perfect. I'm going to erase it in a second, but in fact, I'll just erase it right now because we're going to go to Desmos and do it. All right, but I still know the equation of the asymptote would be y equals negative 2. What's the y-intercept? So plug in 0. So if I plug 0 in here for x, so I'd have 3 over 2, 0 plus 4 is 4, and then minus 2. So 3 over 2 to the 4th, let's see, that would be 81. 3 to the 4th is 81. 2 to the 4th is 16 minus 2. So let me grab my calculator. Or you know what? Let's just go to Desmos. So 81 over 16 minus 2. Let's see. So 81 divided by 16, subtract 2. So there it is, 3.0625, which I could also get off the graph as well. Where was that supposed to be? Oh yeah, 0, 3.0625. All right, so let's graph everything. I want 3/2 x plus 4 minus 2. Now, to put x plus 4 up here, you have to put parentheses. You got to go up to the power and then put parentheses. X plus 4, and then it's minus 2. All right, so you can see that the x-intercept is there for you, the y-intercept is there for you. X plus 4 minus 2, yeah, that's right. Okay, so if you need any of those things, you can graph the asymptote if you like. All right, so let me look back at my graph. Negative 2.29, 3.06. So 2.29, 3.06. All right, so my curve goes up here and it comes down to the left. Okay, so the domain. The domain is everything. This thing goes to the left, to the right. You can plug any number you want in for x. So the domain is all real numbers, negative infinity to infinity. But the range is not. The range is held by that horizontal asymptote. Nothing is below that line of -2. So the range is everything from -2 up. So remember, it doesn't touch -2, even though it looks like it might, but it doesn't touch -2, and then it goes up from there. So that would be the height. The end behavior, as x goes to negative infinity, so as it goes off to the left, it approaches a height of -2. And as x goes to positive infinity, so as you go to the right, the graph just goes up, 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 so infinity. All right, and that is it for the first page. On the second page, given this exponential function, 0.4 to the x, answer the following. Is this growth or decay? Well, this is decay because the base is less than 1. If the base is bigger than 1, then that's when you get a growth function. All right, write the equation for the same parent function, but transform it by moving it 3 units to the right and 1 unit up. So I'm going to keep this 0.4. 3 units to the right, so I'll put x plus 3, and 1 unit up, I'll put plus 1. What's the horizontal asymptote of this new function? So remember, the horizontal asymptote is controlled by the upward or downward motion of your graph, so the horizontal asymptote will be y equals 1. All right, so go to Desmos number 5 and graph this function, 2 to the x minus 5. All right, here we go. So 2 to the x minus 5. All right, and I think it was asking me for the 0 in the next question, right? So remember, the 0 of a function is the x-intercept. X-intercept, 0, root, solution, so 2.322. Or you could put it like this, 2.322, comma 0. Okay, so the 0 of a function is not when you plug in 0, but it's when you get 0 as an answer. All right, what's the y-intercept? Now I can find the y-intercept very easy myself. All I have to do is plug in 0 for x. So if I plug in 0 right here, 2 to the 0 is 1. 1 minus 5 is -4. I could also look at my picture, and there it is. All right. What is the equation of the asymptote? Remember, the asymptote is controlled by any upward or downward motion, so my asymptote is y equals -5. All right, so now on the next part, we're switching over to logs. So this is a log function I've given you right here. So notice that it is everything to the right of -3. So here's my asymptote, x equals -3 right there. And everything is to the right of that, so that's my domain. That's the width of the graph. So -3 to infinity. It's not touching -3, even though it looks like it's touching -3, but it's not. The range is everywhere. It goes down forever. As this goes right, it goes up forever. So the range is -infinity to infinity. And remember, logs and exponents are inverses of each other. And so that's why we get this switch off. With exponential functions, you can plug in anything you want, but your range is restricted, right? So remember back here, my domain was right here. It was anything I wanted, but my range was restricted. So that's the opposite of what's going to happen with a log function. In a log function, your range is anything you want, and your domain is restricted. So it's like flip-flops. All right, so next question. What's the equation of asymptote? Well, we discussed that before. X equals -3. What is a solution? 0, x-intercept, root. So I have that on the graph for us here, -2.9 and 0. Or you can put x equals -2.9, whatever. All right, letter D. This little concept question here. Since the points -2, 1, so there it is, and 7, 2, are on the graph of this log function, what points would be on the inverse automatically, the inverse of this function? Well, you know inverse means two reversed points. So the inverse points would be 1, -2, and the other point would be 2, 7. So if I graphed the inverse of this, the exponential function that was the inverse of this, those points would be on there. All right, given this log function, write the equation for the same parent function, but transform it by moving it 2 units to the right and 4 down. So I'm going to write y equals, you write f of x, but I would put log. Remember, there's a base 10 there, but you don't have to write it. So you can put a little 10 right here if you want to, but you don't have to. It's assumed to be a 10 if you don't write anything. So I'm going to move it 2 to the right. So x plus 2 and 4 down, so that'd be -4 on the end. All right, number 8. Graph this in Desmos, so log base 10 of x plus 2 minus 5. All right, so remember to graph this, all you do is simply, what was it? X plus 2 minus 5. So 1 equals, just type in the word log, it knows it's base 10, x plus 2 minus 5. All right, so left 2, down 5. So my asymptote is going to be -2. All right, so the asymptote going up and down there is -2. X equals -2. So this question is asking, as x approaches -2, what does the value of y do? And so we can take a look at it and see. As you approach -2, approaching it from the right, look at that y value of that point. It's just getting smaller and smaller and smaller. I lost it there. Smaller and smaller. It just gets smaller. Down to -infinity. As I go to the right, my y value gets larger and larger and larger. So this guy goes to -infinity. This one goes to positive. Right. Oh, and I say I forgot part C. What would the vertical asymptote be of what you found in part A? And I guess I should have put a B right here, shouldn't I? All right, so the vertical asymptote. Remember that a log function normally, when you start, has a vertical asymptote of x equals 0. So when you graph a log function, it's normally starting right in the center. And then if you move the graph left or right, that's when this thing moves. And so like this one moved left to -3. Well, if you are going to take this problem that we did right here and move it to the, what did we do? Move it to the left 2, that would be your new asymptote. So your new asymptote would be x equals -2. So the left or right motion controls the asymptote. So this time, because remember, it's the inverse of exponentials. In exponential functions, this number controls the asymptote movement. But in log functions, this number controls it. All right, and number 9. So number 9, this is just flipping back and forth between exponent form and log form. So if we saw this log expression, log base 2 of 8 equals 3, we would know to write the exponential function or exponential equation 2 to the 3rd equals 8. So remember, it goes like this: base, power, answer. Okay, so same thing here: base, power, answer. So x to the z equals y. So that one doesn't really make much sense, but it's just about knowing where the pieces go, right? And I think I'll do this one on the end here. I'll just do the next one, never mind. So remember, we need a base. So here's my base is 5. So I do log with a base 5. The 5 goes underneath. The power goes on the other side, so 3 goes here. And the answer, 125, goes next to the word log. So base, power, answer. So here I would write log base 4, because there's a base of 4 in this problem. I leave a little space. I'm going to put the power on the other side. So base, power, answer is 1 over 16. Okay, all right. And then this next one here, base, power, answer. So do log base A. My answer goes next, and my power goes on the other side. So again, that one doesn't make much sense, but it's just about transforming. All right, so this last one, base, power, answer. So 10 to the 0 equals 1. Now, when you write an expression like this, it has to be true. So like, yeah, 10 to the 0 is 1. 2 to the third is 8. So you have to be able to write something that's true. I mean, that's how it's supposed to work out. All right, that's it. See you in class. Bye-bye.